So continuing on, refer to the table of integrals if required, then find the integrals below. We have here the integral of 1 over 6 plus x squared. From our table of integrals, we have the integral of a squared plus x squared is equal to 1 over a inverse tan x over a plus c. In this case, our a is the square root of 6. So our integral then equals one over the square root of 6 inverse tan x over the square root of 6 plus c. Always have your plus c when you're integrating. A constant differentiates to 0, but you don't know what that constant is. Now, this one was the inverse tan. However, the integral of 1 over 6 minus x squared, that is not inverse tan. Our table of integrals, we have dx over a squared minus x squared is equal to 1 over a, there's actually two of them here, tan, inverse tan, x over a plus c if our x is less than a, and 1 over cof inverse x over a plus c if x is greater than a. Magnitude of x is greater than a. So a is once again the square root of 6, and our integral 6 minus x squared, which is going to be 1 over root 6 1 over root 6, it should be like that, inverse tan root 6 plus c if x is less than a, 1 over root 6 cof if x is greater than a. Right. Later on, we're going to be doing partial fractions. So you can actually find an alternative for 1 over 6 minus x squared, but we'll look at that later. Okay. In each case, using logarithmic differentiation, find the derivative dy dx, or find dy dx. I actually love logarithmic differentiation because, I mean, it just shows you how strong doing a tiny little thing, or how much easier doing that tiny little thing makes life for you. So if we take the log of both sides, we have log y is equal to the log of 3x to the minus 2x. Now, you can't take the minus 2x out the front yet. We need to first split this up because it's 3 times by x to the minus 2x. So, using log rules, this is a product which is equal to, like that. And this is a huge mistake that is made. I mean, logs are actually taught in high school, And quite often, as soon as you see a power, I've done it myself, you're assuming that power is for both the 3 and the x. It's not. It is only on the x. Now that we've split it up, we can actually write this out, because now it's a power minus 2x log x. Differentiate both sides. Now, on the left-hand side, it's implicit differentiation. So differentiate with respect to x. We have 1 over y, dy dx, because it's implicit, because we're differentiating with respect to x. And the right side, log 3 goes to 0. And then the second one is first differentiate the second, plus the second differentiate the first. So the 2x goes to 2. That there, as you can see, cancels out. And we have, bring the y over to the other side. So multiply by y both sides. Now we can take the 2 out. Minus 2 outside of 1 plus log x y. And then we need to put the y back in. So our derivative, minus 2, 1 plus log x, and our y is 3, x to the minus 2x. So we bring that 3 to the front. And we have minus 6, 1 plus log x, x minus 2x. I mean, that's just it. Just a simple thing of taking logs of both sides, and all of a sudden it makes it so much easier to differentiate. So we do the same thing, but this time we do have brackets. So if we take the logs of both sides, we have log y is equal to log brackets. So that means this power is for both of them, which means we can bring that power outside. All those log rules. And now we can differentiate with respect to x. With respect to x. So we have 1 over y. This is implicit on this side. And we have first differentiate the second. Times by, well, 3x has got to be differentiated, divided by 3x. Plus the second differentiate the first. So minus 2 log of 3x. That there cancels out with that one cancels out with that one. That means we are left with 1. So we've got minus 2 outside of 1 plus log 3x is equal to that. Multiply through by y. It's minus 2, 1 plus log 3x, y. And then we substitute our y back. (3x). And this time it's 3x to the power of minus 2x. So we're not bringing that 3 to the front. We have to leave it there.